Welcome to The Explainer. Today, we are diving deep into one of the most powerful and, let's be honest, sometimes confusing patterns in modern software: event-driven architecture. It's the secret sauce behind a lot of highly scalable and super responsive applications. So let's get into it.
To really wrap our heads around this, let's just start with a simple question that kind of flips the script on how we normally think about software. Most systems we build are like a library clerk, right? They just sit there, wait for you to make a request, then they go find what you asked for and bring it back. But what if your system was more like an emergency broadcast system? What if it just reacted instantly the moment something important happened? Well, at the very heart of this whole style is the event. And an event is just a simple, unchangeable record that something significant happened. Think of it like a line in a logbook. Once it's written down, you can't change the fact that it occurred. It's just a notification of a change in state. It's not a request for anything. So, for example, when a user places a bid, they're not asking for data. They are triggering an action that the system now needs to react to. Okay, so with that in mind, what is event-driven architecture, really? Let's look at the big picture. At its core, it's a software style that's designed completely around producing, detecting, consuming, and most importantly, reacting to these events.
It helps to compare it with the traditional model. See, the request-driven world is all about ask and wait. You make a call, and your application is just stuck, waiting for a response. It's synchronous, and it creates these really tight dependencies between your services. Event-driven is the complete opposite. It's react and go. You fire off an event and just move on, totally asynchronously. This is what allows your components to be loosely coupled, which means they don't even need to know about each other to do their jobs.
So, how do we actually build this thing? Well, there are two main patterns, or what we call topologies. Let's kick things off with the first one, the broker topology. I like to think of this one as a chain reaction. And this pattern, you'll see, is perfect when your main goal is extensibility, being able to add new features really easily. In this pattern, there is no single boss, no central orchestrator telling everyone what to do. An initial event gets sent to a central message broker. You can think of it like a post office. Then, any number of event processors that are interested in that kind of event can just pick it up and do their job. And when they're done, they might publish a new event, which kicks off other processors further down the line. It's all very decentralized. The source material uses this fantastic analogy for this. It's like a relay race. A processor grabs the event, that's the baton, it does its part of the race, and then it passes it along by creating a new event for the next runner. And here's the crucial part. Once it hands off that baton, its role in that specific workflow is completely over. It's now free to grab the next baton and start running again. Let's make this real with a retail example. Okay, so a customer places an order. The order placement service creates an order-created event and just fires it out. Now here's the magic. The payment service, the inventory service, and the notification service all pick up that exact same event, and they start working in parallel. They are completely independent of each other. This parallelism is what gives the broker topology its incredible performance and scalability. And since everything is so decoupled, it's super easy to add, say, a new shipping label service later on without touching any of the old code. But here's the catch. With no central coordinator, if that payment service fails, how does the rest of the system even know that the overall order process is now broken? This lack of workflow control and this seriously tricky error handling is the major trade-off you make. Right, so to solve those problems, the chaos of the broker topology, architects came up with a second pattern, the mediator. And if the broker is a chain reaction, the mediator is an orchestra conductor. This pattern is built for those complex business processes where you need absolute control and recoverability. The key difference is right here in the diagram. You've got a central event mediator. So instead of components just shouting events out into the void for anyone to hear, they send their initial event directly to the mediator. The mediator then takes complete control, and it orchestrates the entire multi-step process from beginning to end. Let's look at our retail example again, but this time with our conductor. The place order event goes straight to the mediator. The mediator then executes step 1. It sends a specific command to the order placement service, and only after that's done and it gets the thumbs up does it move on to step 2, and so on. It makes sure everything happens in exactly the right sequence. So this is the really crucial point, the style of communication. The mediator isn't just announcing that something happened. It is issuing direct commands, like process payment or adjust inventory. and it actually waits for an acknowledgement that the task is complete before it moves on to the next part of the workflow. This gives it total, granular control.
The benefits here are pretty obvious, right? You get fantastic control over the workflow, which makes handling errors and recovering from failures much, much easier. But, of course, there's always a trade-off. That central mediator can become a serious performance bottleneck, and the individual services are now more coupled to the mediator, which makes the whole system a little less flexible.
And that brings us right to the heart of the matter for any architect who's thinking about this style. Which one do you choose? It's the big dilemma.
This is such a classic architectural decision. I mean, if you've got a complex financial transaction where every single step has to succeed or the whole thing gets rolled back, you absolutely need that fine-grained control. You need a predictable workflow. In that case, the mediator is your obvious choice. But if you're building, say, a social media platform where you want to be able to easily add new kinds of notifications, well, then the broker's flexibility starts to look really appealing. So the crucial point boils down to this. Are you optimizing for flexibility or for control? The broker gives you that ultimate decoupling and extensibility with its fire and forget model. The mediator, on the other hand, gives you a tightly controlled workflow using more of a command and control approach. Neither one is better than the other. It all just depends on the problem you're actually trying to solve. Okay, let's zoom out for a second. We've talked about the two topologies, but how does event-driven architecture as a whole stack up across some of these key system qualities? The authors of the source material put together this fantastic scorecard, and it rates the architecture on everything from cost all the way to testability. Just take a look at it for a second. Now, I want to highlight two ratings that perfectly capture the core trade-off of this entire style. First up, look at this, a perfect 5-star rating for both performance and scalability. And it's pretty easy to see why, right? The whole asynchronous, parallel nature of this architecture is just built for high-throughput, high-performance systems. This is its superpower. But then you look at the other side of the coin. Oof, it gets only 1 star for simplicity. And why is that? Well, think about it. When you have dozens of decoupled services all reacting to events, trying to trace a single business process from start to finish can be incredibly, incredibly difficult. Debugging and testing become a huge challenge. So after all that, what are the key things you really need to walk away with from this explainer? Let's break it down one last time. Okay, number 1. EDA is all about building scalable, reactive systems using asynchronous communication. Within EDA, you've basically got two choices: the broker, which is decentralized and built for pure speed and flexibility, and the mediator, which is centralized and built for control and reliability. And finally, the fundamental trade-off you always have to be thinking about is that you are buying all this amazing performance and scalability, but you're paying for it with simplicity. And this really brings us to the final, critical question that every single team needs to ask itself. Event-driven architecture offers just unparalleled power for building modern, resilient systems, but are you, and is your team, really prepared to tackle the complexity that always comes along with it?